Hey everybody, welcome back, and we're going to do comma-separated integers in the more advanced practice lesson. Now, as you can see, this is significantly, well, I guess it doesn't say significantly more difficult than the TAA, but it is. It is going to be a step up in terms of the difficulty that you've faced so far, but that's okay. For any of those of you who saw the little experimental streams we did maybe like a week or two ago, by the way, more streams are on the way. That was just sort of like a litmus test. But for those of you who saw that stream, you can definitely attest to the fact that I butchered this problem, which is to say, did a terrible job of not following any of my own advice and spent I think it was like an hour on stream, which is why that stream isn't there anymore. But nevertheless, a little bit of breakfast after a good night's sleep, and we were able to re-attack the problem. And so we're going to do the actual solution here, but keep in mind that if you've been working on this problem and having a large amount of difficulty with it, it's okay. It's okay to come here and check out the solution and see what it looks like, and then you go back and try to attack it again. The idea that you want to come away with is that it's okay to look at solutions, provided that you can start with a blank page and then recreate the solution yourself. If you can't do that, you might give yourself the impression that you can do problems that you can't, and you want to avoid that because with a little bit of work and some, nervous anticipation, you probably can do the problem in question. So let's go ahead and jump into it. You're going to create a function called solution, which will take in an array of increasing integers and return them in the format described below. A format for expressing an ordered list of integers is to use a comma-separated list of either individual integers or a range of integers denoted by a starting integer separated from the end integer in the range by a dash. Okay, that's probably going to be easier once we look at it. The range includes all integers in the interval, including both endpoints. It is not considered a range unless it spans at least 3 numbers. For example, an input of 12, 13, 15, 16, and 17 would return 12, 13, 15 through 17. Complete the solution so that it takes a list of integers. List is a very common way that other languages will state array. Just keep that in mind. Takes a list of integers in increasing order and returns a correctly formatted string in the range format. They're just describing this. Below is an example of your code running, assuming you have solved the problem correctly. So for this list input, 6 isn't part of a streak. 3, 2, 1, 0, 1, that is a streak. So that becomes -3 to 1. Okay, so here we see that if there is a negative streak, which is to say if the streak ends on a negative, it's just going to look like this, a dash and then the minus sign for negative. Okay, so keeping in mind that this is a very difficult problem, we're going to go ahead and bring it out of this area and into Replit. The idea will be we want to give ourselves plenty of room to mess with things. So we'll say integers. We've got a couple of calls. Say let result 1 equal solution. Oh boy, console log is not a thing. Console.log is. Result 2. Okay, so we've got 2 calls to our function setup, and now we need to go ahead and solve it. So this wasn't part of it, but what I would suggest is that if the list comes in with no values in it, then it hasn't really described what we should do, and if it comes in with a less than 3, we don't really need to worry about that either, right? So for our edge case, we could say something like, well, the edge case could probably just be integers dot length needs to be greater than 0. And let's assume that there is no version of events where it's going to come in just by itself. By itself. We're not getting an empty array. We're just going to assume that. And then integers dot length needs to be less than 3. If it starts to become 3, then we could have a streak, and so we'd need to actually do something. If this is the case, we either have 1 value or 2, and if that's the case, let's just return integers dot join on a comma. Now, that's going to become useful for us later on because joining things on a comma is sort of the approach that we're going to take. What we're going to do is essentially push either a value, like an integer from the input array, or a streakified version of some portion of the array. And then once we get all of that in an array, we could join it so that if this is an element of the array, this is an element of the array, this is another element of the array. And if we join all those on a comma, then we'll get a string that looks exactly like this. So that's the overall approach, and let's see if we can do this. So we'll say create a result array, return the result array joined on a comma. So that seems like a reasonable start. Now here's what I would say. In the event that you don't know when you're going to stop iterating, or the iteration might not go by 1 every time, which it won't if we get a streak, a while loop is usually a good way to go about things. But regardless of whether we use a while loop or not, we know we're going to need to iterate over the integers array. Now how we do that iteration is a little bit, well, it's up to us, right? And so I would suggest this. And this is actually what I did incorrectly during the stream, but we're going to do it correctly now, is that what we want to do is at any given point we want to look at 3 of the integers. We want to look at one at a starting position, one in the next position, and then one that we could theoretically say is the end. Now what we'll do with that is we'll start with a index variable that's going to point here, one that's going to point here, one that's going to point here. Now, eventually it'll make sense why we're doing that, but what you can determine by the problem is that we need 3 in a row to get a streak. So in order for us to be able to check 3 values in a row, it's going to help us to have 3 index variables. So we'll say create start index variable equal to 0, create next index variable, and variable. Got to get in the habit of starting calling these bindings. There is no difference between variables and bindings when you hear me describe them. Binding works better for my mental version, or like mental image of what they're actually doing. We would suggest that rather than a variable for result 1, we have a binding within this scope. The result 1 moniker or name is bound to whatever value is delivered by solution. And that's only true for whatever scope we're in, which, I don't know, I like it better. So create a result array, create start index binding equal to 0, create next index binding equal to 1, and then create end index binding equal to 2. Okay, so what we're going to do is we iterate over the integers array, and the first thing we're going to check is we're going to see, well, we have two possibilities, right? One is that we have a streak, and one is that we don't. Now we need to figure out how it is that we're going to determine if we have a streak. So if we have a streak, there's a couple ways we could do this, but I'm going to suggest that the value at end minus the value at next needs to be equal to 1, and the value at the value at next minus the value at start needs to also be 1. So we'll say if value at end, that might be a quicker way to write this in pseudocode, but that's okay. If value at end is minus value at next is 1, and value at next minus value at start is 1, then we know we have a streak. Otherwise, we do not have a streak. So, in the event that we don't have a streak, I would suggest that what we do in that case is easier. The first thing we're going to do is, if we don't have a streak with start equal to the first value, next equal to this one, and end equal to this one, all we essentially need to do is move everything over by 1. We need to add whatever value is here to our result, because we know that it's not part of a streak. So whatever the value at start is now not part of the streak. And if it's not part of a streak, we need to add it to our result. So we'll say add value at start to result. Okay. Then we're going to, now I'm going to write some shorthand for this, but it's essentially, it's start, next, and end are going to be equal to next, end, and end plus 1. Now all we're doing with that is we're just saying start now needs to point here, next needs to point here, and end needs to point here. And that's in the event that the first one is not a streak. So start. Okay, cool. So if we have a streak, now here's where we need to get a little bit clever with what we're going to do, which is to say, I'm calling it clever because I publicly butchered this, so it's nice to make myself feel better by saying that it requires cleverness. So we have a streak, and if we have a streak, we need to find out how long that streak is. So here's another one where we're going to write something that seems a little bit more like code, but it's okay. We're going to say while, and then while, what we're going to do is we're going to leave start where it is, and we're going to continually move end and next over by 1. So the first thing we need to do is make sure that while we're doing that, we need to make sure that the streak condition is still the case. And the streak condition is essentially this part right here. Oh, it's not otherwise. While value at end minus value at next is 1. And all we're doing there is we're essentially just maintaining that there's still a streak going on. If there is still a streak going on, we need to do a couple of things. We need to make sure that we continually move end and next, basically like over 1. So we'll continually, and we're going to make use of this again, where this is not what the code will look like, but we're essentially going to say start is now equal to next, next is equal to end, and end is equal to n plus 1. But for this one, we're going to say end, we'll say next and end is equal to end and n plus 1. Now all that's going to do is that's going to move our streak along, and we're going to continually check until we find out that we don't have a streak. We don't have a streak whenever this while loop ends, because the condition at some point is going to be changed by this. So after that's the case, we have a couple of things to do. We know we have a streak now, and we know that streak essentially goes until end, which is to say end minus 1. At a certain point, end is not going to be part of the streak. So let me show you what I mean. We have next is right here, and end is right here. So above that, I'm going to write our little S for start. Oh geez. S for start, N for next, E for end. So first thing that we do is we find we have a streak. Then we need to continually move end and next over 1. So I'm going to space this all out initially so that I don't keep moving to the next line. All right, that's going to be plenty. So what we're going to do is we find out that while these two are still here, we're going to move end to be whatever end was plus 1. So end becomes here, next becomes there. But calling it end and n is not a good way to do it. So end and next. So why not? Well, because they're too long. So end is -1, n is equal to -2. The value at end minus the value at next is still 1, so we keep doing this. We move end here, and there, end there. Wow. All right. So that's still a change in 1, so we're still part of the streak. Still part of the streak, not part of the streak. So that means that when we lose our streak, there's a couple things that need to happen. One is, this is not part of the streak, so we need to essentially cut the portion of the array that goes from, okay, well S got moved, right? S is going to be here. The reason S is going to be there is because we already got done with the case where we don't have a streak. We did all of this, essentially, and moved everything down by 1. So this is not part of what we're looking at anymore. We already pushed that to the array. It'll be fine. And eventually it's going to come out as -6, so no worries. We now have S, or start, at -3, at the index of -3, and we have end at this value 3 here. Now our streak is this right here. So what that's going to mean is that if we have a value for S, where we want to start the streak, and we have a value end that is 1 past where our streak needs to end, if you've been doing the course really diligently, you might have used slice a bunch. Slice is an array method that is going to let us cut basically from S to just before end, if we use S and end. So we'll say slice, we'll save a slice of input from start to end. Now, the reason we say start to end is because of the way the slice works. So we've now sliced this portion of the array. We're going to assume that we can take that portion, create proper or string format of slice and add to result. So that might seem a little bit complicated, but when we get there, you'll find out that that's pretty easy. If we know the end value and we have an array that's going to basically be an array from -3 to 1, we'll take this value and this value, combine them in a string with a dash in the middle, and then push that. So string format is going to refer to basically this. But that'll be simple, and we don't need to worry about it for right now. The next part is where things get not complicated necessarily, but just a little bit, we have to make sure that we're careful about what we're doing. So this is the current state that we had with start, next, and end. What we want, because this is the streak that we have, we need start to be here. So what that's going to mean is that we say start is equal to end. So now S is here, we need N here and E here, which is to say start is equal to end, next is equal to n plus 1, and end is equal to n plus 2. Now that we have that, it's going to come all the way back up here to make sure that we're still iterating properly. So if we've gotten to the end of the array and start is now the last value, then of course it would stop and, well, we would not have a streak, and so we would end up pushing start. Otherwise, I would say that we have done everything that we need to in terms of pseudocode. We're going to create our start, next, and end. We're going to, if there is a streak, then we come to the end of the streak, slice off the portion that represents the streak, format it, reassign our indexing variables, and then continue. Otherwise, we don't have a streak, and we just add the current value to start, or sorry, add the start value to, add the value at start to the result, and then keep going. When we finally have done all that, we'll return the result array joined in a comma. So let's go ahead and comment all of this out, and let's go ahead and code it out. We'll say let result equals an array, let start equal 0, let next equal 1, let end equal 2. Iterate over the integers array. Now, the reason that, well, I'm going to use a while loop. And the reason I'm going to use a while loop is because I want the adjustment of my incrementing or my index variables to be based on the logic I've described inside of here, rather than some kind of like, always just add 1 to it every time. So what I need to make sure is that while start is less than the length of the array. It is going to be similar to a for loop in that we're going to limit start the same way we would I if we were using a for loop. You know, a regular for loop where I is equal to 0 and I is less than, what would you call it? The length of the array. And what this is going to mean is that at a certain point, start might be assigned as the array.length minus 1. And what that means is that we've basically gotten to a value like 17, which is not part of a streak, at which point we won't have a streak because this part won't be true. And we'll just push our start to the result, and then we'll adjust start so that it no longer satisfies the while loop, and the while loop will close. So this one's going to be a little bit tricky, but that's okay. So if, did we call it array? We did not. We call it integers. So if integers at end minus integers, go on then, at next is equal to 1, and integers at next, I'm all thumbs today, integers at start is equal to 1. Oh boy, we messed this up badly. Alright, so if, excuse me, if integers at end minus integers next is equal to 1, and integers at next minus integers at start is equal to 1, then we're going to have all of this good stuff. Otherwise, we don't have a streak. Now, I'm going to code out the we don't have a streak part first. And it's like, why? It's like, I want to. Mostly because I know how it's going to look, and I think it would be, well, easier to start off on the good foot. So start is equal to next, next is equal to end is equal to end plus 1. And we could probably just return result, result Okay, so the only thing we have left now is all this jazz inside of where we actually have, um, a streak. So while value at end minus value at next is 1, and we just did something very similar to this, so it's going to essentially be this. While value at end minus value at next is 1. And this is the case where we have a streak. So essentially this is that part where we're just moving next and end so that end is going to eventually point to the value that is just outside of the streak that we've just discovered. So in this case, we're going to say next is equal to end, and end is equal to end plus 1. Save a slice, so we'll say let sequence equal integers dot slice, and this is where that pseudocode and all that planning phase that we did makes it so much easier for us, which is also something I didn't do on the stream, which is you want to make sure that what you're writing in your pseudocode works, at least in your mind, before you start coding, because once the code gets on the page, you really want that code to work, and yeah, it's just, it can get ugly. But that's okay. We're none the worse for the wear. Let sequence equal integers.slice from start to end. This is going to cut from start, including start, to just before end. And we determined previously this means end is now outside of the bounds of our streak, because it was set to whatever n plus 1 is, and the last time that this was true was when end was equal to what it was before it was just reassigned. Now, if you have trouble with that, I am probably going to include a, what would you call it, a spreadsheet. Maybe I'll do this in the next solution, but I have a spreadsheet where I organized like an actual, let's look at it in cell shape and kind of understand what we're doing. But what we did at the beginning is close to that, so I might not have it as well. Create a string format of the slice and add to result. So result.push is how we add anything to result. And this one's going to be one of those where I'm going to use a template literal, and I'm going to use a template literal because it's way easier to. So there's the dash, and there's the second one. So a template literal is basically a way to use a string without using the whole string plus another string. This lets us interpolate a value of some variable inside of a string and without having to worry about any formatting. It just takes the value, stringifies it essentially. Well, we won't worry about that. But what we want is, I'm going to call this SEQ rather than whole sequence, just because to try to make the type big enough to have everyone see it versus try to make it, not blend over to the next line can be a little tricky. So sequence at 0, because we want the first value in there. And I'm not doing this right. There should be, okay, there we go. Sequence at sequence. I mean, this we want, so we just created a sequence, and our sequence is essentially this, like an array that looks exactly like that. So what we want is we want the first value and the last value. Again, if you've been paying attention to the course, we know we can get the last value of an array by saying the length minus 1. Okay, so sequence push, and then we want to do this whole reassignment. So start is equal to end, next is equal to end plus 1, and then end is equal to end plus 2. And that's equivalent to what we were discussing with if we have this going on, we essentially want to reassign start to be this value, next to be this value, and end to be this value. So, okay, now it might seem like we've been going in circles a little bit, but the reason that we did that is because we're now done. We've literally solved the problem twice, once in code and once in pseudocode. And I would suggest that because we did that, we can just go ahead and hit run now, and hopefully we're looking at a correct answer. So let's go ahead and do it. Four, -1, 2, 3, 5, 6, 12, 15. Okay, looking good. Let's go ahead and grab this. The computer's making that sound that I've been pressing it too hard, so we hopefully want to sort this out quickly. Let's go ahead back to the code input window, paste it on in there. Looking as good as code can when you're just glancing at it like that. Let's run the tests. Victory for the home team. Excellent work, everybody. Thanks for watching. Hope you enjoyed it. Let's have one last look at the solution. Nice and slow, just so everything, well, let's scroll it all over. Just nice and slow for anybody who wants to copy down the solution. Also, you can always feel free to DM for solutions. It's not the intention to have problems in here that don't have solutions. There are certainly other ways to do this, but this is one. So, thanks for watching, hope you enjoyed it, and we'll see you in the next one.